So today we're doing Unit 7, Lesson 3. We're going to have applications of reference angles in the cast rule, which we learned previous lesson. This is the overview what we're going to do today. We're going to determine the exact trig ratios, rotation angles from 0 to 360 given a point on the terminal arm. Then we're going to determine the trigonometric ratios for rotation angle from 0 to 360 given a different trig ratio for the angle. So being able to use the cast rule and reference angles, we kind of come to the conclusion of what they're asking us about. It's 0 to 360, meaning just one time around the circle. And then solve equations from sine theta equals A, cosine theta equals A, or tan theta equals A, which we're going to use inverse cosine or tangent or sine, which is a calculator move that we will do at the end of the lesson. So a quick review from previous lesson is the setup of the reference angles and the cast rule. So remember, cast rule starts down here, okay, C, A, S, and T. So remember, C means cosine's positive, everything else is negative. A means all positive, S means sine's positive in this region, T means tan is positive in this region. Okay, and so that's what your cast rule does for you. In terms of reference angle, so remember your reference angle for quadrant 1 is equal to the rotation angle. So if it's 60, then that's your reference angle. If your reference angle is here, it's 180 minus the reference angle to get your rotation angle. So if I say reference angle is at 50, you go 180 minus 50 will give you the rotation angle to that terminal arm. Okay, down here, same thing. We'll just use 50 again. If I say it's 50 here, you'd go 180 plus 50 to get this rotation angle, which that case would be 230. And then over here, if I said this was 50, if we're going to go all the way around, it's 360 minus 50 to get that whole thing there. So 360 minus 50. So in this case, 310 would be our rotation angle with a reference angle of 50 in quadrant 4. Okay, so that's a quick review from yesterday, so hopefully that isn't too difficult. Okay, we can turn the signs or trig ratios, and again here, C-A-S-T, they have it here for you again. I stick with cast rule, and then here's our trig ratios. What I like to point out to you guys is understand that sine is kind of linked to y, cosine is linked to x. This will make more sense when we get to the unit circle. Okay, but think cos x sine y, and then tangent is a comparison of y over x. Okay, so something to keep in mind as we go. All right, so now exact values of trig ratios given a point at terminal arm. So, example 1. The point -3, 2 lies on the terminal arm of an angle theta in standard position. Complete the following procedure. Determine the values of the primary trig ratios. Okay, so here we go. We're going to do the first thing we're going to do is we're going to put -3, 2 on here just to kind of see where that position is. So we're in quadrant 2. Okay, so right there's our terminal arm. Okay, so first thing it says, sketch the rotation angle on the grid and mark the point -3, 2. So I'm going to change colors just so we can see what the rotation angle is. The rotation angle is here. That's the rotation angle. Okay, if I want to make a little note to myself, that's the rotation angle, but this right here is the reference angle. Reference angle is always back to the x-axis, so that's important for us to remember. So once we calculate the exact length of OP, so OP is from the center to the end point. So it wants me to find the diagonal. So the diagonal, if you're saying, well, I don't see a diagonal, what are you talking about? Well, don't forget, we look at these as triangles. So here, that's 2, that's -3. So we're going to use Pythagorean theorem to figure out what OP is. So I'm going to go -3 squared. It doesn't matter if you do 3 or -3. I know some of you are saying, oh, I thought distances can't be negative, and you are correct. But when we square it, it's going to work out to be the same. That's the beauty of Pythagorean theorem for this section. So -3 squared is 9. Plus 4 equals 13. And then we square root the 13, because it was going to be OP squared. So we square root both sides, and so OP is square root 13. So that's the length there. And so now what we're going to do is, we now have OP essentially is R. So if you go back to the top there, we now have X, Y, and R. Okay, if you're not following me, we know that X is -3, we know Y is 2, and then we know that R is root 13. So sine is Y over R. So that means it's going to be 2 over root 13. We like to rationalize that based on our radical rules. So we get 2 root 13 over 13. So that would be our sine theta. Okay, cosine theta is x over r. So it gives me negative 3 over root 13. Again, I'm going to go and rationalize that. So I get negative 3 root 13 over 13. Okay, so we're good to go for cosine theta. And the last one we're going to do is tan theta. Tan theta is y over x. So tan theta is the easy one. It's simply going to be 2 over negative 3, which you can also write as negative 2/3. Okay, and that's it for example 1. Okay, let's move down here to example 2. So example 2, the point negative 4, negative 2 lies on the terminal arm of angle theta in standard position. Determine the exact value of sine theta. So specifically wants to know just sine, not all of them. So we're on a specific goal for, we need, in order to make this happen, we need y over r. So the thing we have to figure out is r. So we're just going to draw this again. It's at negative 4, negative 2. So it's down here. Okay. Again, just for practice, we don't really need it for this one, but this is the rotation angle. So we have negative 2 and negative 4 for our sides, and we want to figure out what this length is here because we need r. Okay, that's the only thing we're missing. Because right now, if I write sine theta, we know we're at negative 2 over r. So we just need to figure out r. So I'm going to go negative 4 squared plus negative 2 squared equals r squared. 16 plus 4 equals r squared. 20 is r squared. Square root, square root. Remember, from our radicals, we can break that down to 4 times 5. So we get 2 root 5 equals r. So what we're going to do is we're going to put that down here. You can see the 2's cancel, so I have negative 1 over root 5. We're going to rationalize. We get negative root 5 over 5. That would be what sine theta is for this specific problem. Okay, and we go further. So we're now going to do it with different trig ratios. So angle A terminates in the third quadrant, so it's giving you information to help make the decision. You got to use your knowledge of cast rule, and you see a little bit at the top here. I think it's a 4, but there we go. The cast rule and reference angle. So it says angle A terminates in the third quadrant with a sine A of negative 4 over 5. So this is what people understand. Like, how do I know what's negative when it's written right here by 4 or 5? Well, we need to know third quadrant is right here. Okay, so there we know that sine is y over r, therefore the y is negative. Okay, so we have our y is negative 4, our r is 5. Okay, so then it says since sine A, pretty much what I just said, I've done this too much apparently, negative 4 over 5 equals y over r, we know that the point is x, negative 4. So we need to figure out what is x. So we're going to be doing Pythagorean theorem, but backwards. So we have negative 4 squared plus x squared equals 5 squared. 16 plus x squared equals 25. Minus 16. We get x is 3. And it's going to be a negative 3 because we're in the third quadrant. So, so we already sketched the diagram. So essentially, it's over here. It's negative 4, and then we didn't know what, excuse me, 1, 2, 3, erase that here. It's negative 4 for the y. So the diagram that we'll be sketching is we don't really know. We do now, so I'll go ahead and use that. We put our dot right there, and you can see that's at the negative 3, the negative 4. Remember, it's a negative 3. I know it's a little messy because it's in the third quadrant. Okay, and then, so it says use that to determine the value of x. We just did that. And then use the values of x, y, and r to determine the exact values of cosine A and tan A. So cos is going to be negative 3 over 5. That's what cos A is going to be. Tan A is going to be negative y over, or excuse me, y over x, which they're both negative. So a negative 4 over a negative 3, which makes a positive 4/3, which makes sense because this is a t. C-A-S-T, tangent should be positive, and it is. Okay. Very good. And moving on to example 4 now. So example 4, if tan theta is negative 2/3 and cosine theta is positive, find the exact value of sine theta. Okay, so tan theta is negative 2/3. So what that means is it tells you cosine is positive. So if one's negative and one's positive, it kind of tells us what corner we're in. Okay, so again, it's C-A-S-T. So if cosine's positive, we have to be here or here. And then, but it says tan's negative, so it can't be in the all. So that means we're in quadrant 4. Just find the exact value of sine. Okay, so we're finding the exact value of sine, and we're expecting sine to be what? Sine should be negative. Okay, so tan of negative 2/3, remember that's y over x. We know in this quadrant y is negative, x is positive, so we can assume, or not assume, we know that that's a negative 2 over a positive 3. So y is negative 2, x is positive 3. So if it wants the value of sine theta, we need y over r. So we're missing r again. So we have to do Pythagorean theorem again. Negative 2 squared plus 3 squared is r squared. And we're going to get, again, the 4 plus 9, the 13. Okay, so sine theta in this case is going to be, what is my y again? My y is negative 2. Negative 2, so sine theta is negative 2 over root 13. We'll rationalize one more time. So sine theta for our final answer is negative 2 root 13 over 13. Okay, and that's it for that one. Got just a couple more here. Now we're going to talk about inverse sine and cosine. Okay, so solving an equation like sine and sine, cosine, tangent. So the problem is we're actually going to do this like algebra. So if you go back to your basic algebra skills, if you have a 2x equals 12, that's multiplication, so you divide. Okay, same thing, if I have x plus 8 equals 11, I'm going to subtract. I'm going to do the opposite. Well, when we have sine x equals 12, the problem is we need to get rid of the sine. We're trying to get x isolated. So the opposite of sine is sine inverse. Okay, and so you're going to sine inverse 12 on your calculator. And that will kick out what your answer for x is. And that's what this is explaining to you how to do. So we have to figure out what quadrants you can be in. So we have to still use our CAS knowledge, not simply just calculator work where, oh, that's it. Because it might give you the reference angle, and you have to figure out, okay, but it has to be in quadrant 3. Okay, and we'll get to that in a second. So when you do this, determine the quadrants the angle will be in by looking at the sign of the ratio. We just talked about that. Determine the reference angle always between 0 and 90. Remember, reference angle can't be bigger than 90. And draw a sketch in the appropriate quadrants. Once you do that, you're in a second sine, second cosine, or second tan of the absolute value of the given quantity. Determine the rotation angles using the reference angle and the quadrants. Okay? So, and then it always says here, always check the domain, because sometimes it says your answer can only be between 0 and 180. So, here we go. Use the procedure above to solve sine theta of 0.5. So we're solving, so all I'm going to do is I'm just going to go inverse sine to both sides. So that means I have theta, which I'm solving for, sine inverse of 0.5, and this is what your domain is. It has to be between 0 and 360. Okay? So when we do that, you're going to get 30. Okay? Now that is your reference angle. So you have to ask yourself, this is 0.5. Is that positive or negative? Well, it's positive for sine. Sine's positive here and here. So that's where your two answers are going to be. So one answer is going to be 30. because the reference of rotation is the same here. Now, if my reference here is 30, we have to do our thing from the first page of our notes. We have to go 180 minus 30 to get 150, because that is our rotation angle from here. Okay? So your answer for this problem is, a lot of people just put 30. You have two of them. Okay? Your answer is 30 and 150. Okay, let's look at a couple more here. All right, so find the measure of x to the nearest degree between 0 and 360. So again, these two are the same. Where's sine negative? So sine is negative down here, these two. So we know we're going to be in quadrant 3 and 4. So by degree measure, you know you should be between 180 and 360 on these two answers. Those are the type of things I want you to understand. That's conceptual. If you understand that, a lot of the other stuff is going to make it a little bit easier for you. So we're going to go sine inverse of negative 0.8090. Okay, when I do that, you're going to get, it's going to kick out a weird, it's going to kick out a negative 54. The reason it's doing that, it's shooting you this way, because there's nothing up here for it to be. So negative 54, if I do 360 minus that 54, I'm going to get 306. 306 is one of your answers. So 54 essentially is your reference angle. Okay, because that's what it says up there, absolute value. Okay, so now we have to figure out in the third quadrant what would it be. So I'd go 180 plus 54. 180 plus 54, and that would give me 234. So there's your two answers for part A. Okay, I'm just going to erase this little piece here so I have some room. So then again, we're going to go cosine inverse of negative 0.8090. So cosine's negative. So if cosine's negative, that means we're in quadrant 2 and 3. Okay. And so when we put that in there, it's going to give me a reference angle of 36. That's from your calculator. So if I know I'm doing quadrants 3, I'm doing it here and here, that's 36. And that's 36. So what is this? That's 180 minus 36, so that's going to be 144. This is my first answer, and this is going to be 180 plus 36. So again, how am I getting that? This piece here is 180 minus 36 to give me that chunk. This piece here is 180 plus 36. So the other one's going to be 216. All right, last but not least, tangent. So again, tan inverse on your calculator. Remember, you're setting second tan. Negative 2.4586. We'll put that in. That one kicks out a reference angle of 68. Okay. Tan's negative. So where is tan negative? Tan is negative here and here. Because here's A, all is positive, and here's T. So it's not going to be in these two. So 68. We're going to have a reference angle of 68 here, and a reference angle of 68 here. Well, that's not very to scale, but that's okay. So here, this one, 180 minus 68, so we get 112. This one we get 360 minus 68, we get 292 for that one. Okay, again, the angles we just figured out, this angle is 112. This angle is 292. Okay, and we got one more page here with two examples. A couple of kind of investigation things kind of to notice. Okay, so for this one, solve the following equations. Sine theta equals 1. So where is sine theta equal to 1? Okay, well, we'll still do sine inverse of 1, and it's going to give you 90. The reason it gives you 90 because right here is 1 in terms of y. We operate under the assumption that the radius is 1 for our circle that we're kind of going around. And so for it to be 1, boom, it needs to be there, which would be 1 over 1. Okay? And then if you're saying, what do you mean by 1 over 1? Well, my height here for y is 1. And then that makes my r also 1 because that's the radius. So it would be 1 over 1, and it happens at 90. We're saying, what about 270? Well, 270 would not be 1, it would be -1. So that one doesn't work for what we're talking about. But anyways, so that's how that would work in terms of the value of it being 1. Cosine theta of 0. So cosine theta of 0, where's cosine 0? So it's essentially what we just talked about. Cosine 0 right here. Let me change colors here. This is cosine 0 because that's the x. So there's no movement left or right. So this spot and this spot, cosine of theta is 0. So that would be 90 and 270 will be our two spots where cosine is 0. Okay, and then the last one here, we're just going to solve this equation. So we're going to do algebra-wise, just to start, we're isolating theta. First step, I'm going to -1. So I have 3 tan theta equals 3. Well, that's multiplication here, so I'm going to divide 3. Tan theta equals 1. And then pay attention, we're only looking for answers between 0 and 180. So we're doing tan theta equals, oops, tan inverse. Sorry, we inverse both sides now. Tan inverse of 1 equals theta is what I meant to write. Okay, so that happens at 45 degrees. So it's going to, and where's tangent positive? So tangent is positive here and here. However, this section right here is past 180, so it can't happen down there by our restrictions. Okay, so we're going to come back up here. It's simply just going to be 45, which is the reference angle you're given. So your answer for that equation would be 45. Okay, that's all for Unit 7, Lesson 3. As usual, come with questions, and I'll be happy to answer them.